Hello everybody, my name is Cecilia Valdes and today I will be presenting my Lab 1 charge tapes for Physics 2212. The main objectives for this lab is to first set up an experiment in which the electrical interactions between two objects, in this case pieces of clear tape, are observed. Also to determine approximately how much of the excess charge is on one piece of the charged clear tape, and use glow script and physical models to create a computational model of this experiment, and then compare this model to the actual observational experiment. We have a few formulas and key ideas that we'll be working with throughout this lab. First, we have the Coulomb's law of electric force, which describes the interaction between two charged particles at a certain distance. And then we have the relationship of the force and the electrical fields, which just tells us that the force is gonna be equal to the product between the electric field and the charge of a particle. And then we have the electric field of a point charge, which is the force at a certain location given the presence of a charged particle. And of course, the force due to gravity. Also, it is important to note that we will be working with a constant K, which is 1 over 4 pi epsilon naught, which just equals 9 times 10 to the 9 newtons meter squared per coulomb squared. As you can see with the following graphic, the setup of our experiment will consist of placing the tape A below tape B, and well, we're gonna have to consider the following data, like the length of the U-tape, the width of the U-tape, the mass of the U-tape, and the distance between tape A and tape B, which are the numbers written down here, as you can see. Now we're gonna be calculating the charge on tape B. The forces that we're going to be working with are the force of gravity, which points downwards, and the electric force. Since these forces are equal in magnitude and opposite in direction, we're going to get a net force of 0. Then we do the algebra to calculate the charge on tape B. We continue doing algebra, and we get that the magnitude of the charge on tape B is 2.33 times 10 to the negative 9 coulombs. Now we want to calculate the electrons that we have, and what we're going to do is to divide the charge of the tape B by the charge of the electrons, and it gives us 1.456 times 10 to the 10th power. Then we're going to calculate the amount of atoms, and to do that we need to consider the area of the tape, which we calculate by multiplying length times width, and the area of an atom. We just divide the area of the tape by the area of the atom, and we get that we have 3.6 times 10 to the 17th power atoms. So in order to set up the computational experiment, we're gonna have to declare a few variables. As you see, we have distance, the length of the atom, and others, as we already mentioned. First, we're gonna calculate the gravitational force, and then with this result, we're gonna calculate the electric force, as we discussed before. Then we're gonna calculate the charge, and then the electron count. There are the same formulas that we already talked about, just in code. And well, we get that at the end that the deficiency of electrons on a piece of tape is of 1.02135 times 10 to the 10th power, and that there are 3.52 times 10 to the 7th power atoms for every electron on one piece of tape, and that the charge in one of the pieces of tape is of 1.63 times 10 to the negative 9 coulombs. So analyzing our results, we get that some of the assumptions we had to make was that drag or air resistance was not present in this experiment, that also each U-tape had approximately the same charge, and that tape A was a point charge which had a charge concentrated in the center. So to answer the what if questions, if the electrons had positive charge and protons had negative charge instead of what we're analyzing right now, there would not be an effect on the results or on the experiment, because at the end of the day, both if a negative is next to a negative, it will repel, and if a positive is next to a positive, they will repel as well. It is important to to be careful handling the charged tapes, because the contact in general, contact with anything, not only with our hands, can enhance the transfer of electrons or the grounding of electrons depending on the charge that we have in our bodies or in the object that's being in contact. So that's why doing so can change the charge of the original charge of the tape and alter our results.